Lesson 43, Chess. To follow along with this lesson, download the project from the top of our lesson page at zoax.net. In this lesson, we use the material from previous lessons to program a slightly simplified version of chess. Our primary purpose in this lesson is to give a practical example of inheritance and polymorphism. To make the code more understandable, we have left out some of the rules which would make the code messier, but can also be added in very easily. These are castling, en passant, the double pawn move, and pawn promotion. Our program contains a base piece class and derived classes for each type of chess piece. We explained inheritance in Lesson 38. We also have a class to represent the game board and one called chess to run the game loop. Our main function just instantiates a chess game object and calls start on it. The chess class has two data members, one board object to represent the game board, and a chart to represent the current player's turn. The player's turn is either W or B, depending on whether it is white or black's turn. In the constructor, the player turn variable is initialized to W because white moves first. The constructor also calls the default constructor for the board. The board has a single data member that is an 8x8 array of pointers to pieces. The default board constructor initializes all these pointers to null, and then dynamically allocates and places each of the pieces on the board. We covered dynamic allocation in Lesson 36. Any leftover pieces are deallocated by the destructor when the game is over. When the start function is called, we begin the main game loop, which simply calls getNextMove and alternate turn to switch to the next player's turn. Additionally, isGameOver is called for each loop to check whether there is a checkmate or stalemate. The getNextMove function runs a do-while loop until there is a valid move specified. In the beginning of the loop, print is called to print the game board, which looks like this. The board is numbered on the left and bottom by the numbers 1 through 8, which are used to specify moves. Here we have the print function, with the first loop printing the upper left portion of the border with the game board on the right. The first if prints the side border with the numbering, and this loop prints the board. The function called getColor outputs W or B to indicate whether the piece is white or black, and the function getPiece outputs one of these characters to indicate the piece type. For the squares, asterisks are printed to indicate a white square and spaces to indicate a black square. This bottom portion prints the bottom border with numbering. Back to our getNextMove function, we prompt the player for a move using double-digit numbers with digits in the range 1 to 8 to specify the row and column. For example, inputting 24 and 34 moves the pawn in front of the white king ahead one square like this. Once the move is inputted, we check that it is a valid move. The first check makes sure that the adjusted coordinate indices are in the range 0 through 7. Then we check that the source location has a piece and that piece is of the same color as the player whose turn it is. Next, we call isLegalMove to check that the piece can move to the location. Finally, we make the move and test whether the move puts the current player in check. If the current player is not in check, the move is valid. Otherwise, we undo the move, print invalid move, and the while loop runs again to request a new move. The function isLegalMove is a member function in the piece class which checks that the destination is either empty or of the opposite color, and then calls r2isLegal. r2isLegal is a pure virtual function which is overridden for each piece class to check that the source and destination indicate a legitimate move for that particular piece type. Pure virtual functions were covered in Lesson 42. For example, r2isLegal in the knight class checks that the move either moves by one column and two rows, or by two columns and one row. Our function isInCheck is a function in the board class that finds the location of the king of the given color, and then runs over the entire board to see whether any pieces of the opposite color can take the king. After getNextMove exits, alternate turn is called, which simply swaps the color of the current player's turn. Finally, we have the isGameOver function, which first calls canMove to determine whether the current player has any moves which will not put his king in check. The function canMove runs over all the board squares to find each piece of the current player's color, and then runs over all the squares of the board to check whether any move for this piece is legal and does not leave the current player in check. If can move returns false, the current player has no moves that will not put him in check. So we test whether he is currently in check or not. If he is in check, then it is checkmate. Otherwise it is stalemate. This concludes the lesson.